This is the second section in Chapter 6, and we're going to define the idea of impulse. If you're a Star Trek fan and this makes you think of the impulse engines, maybe related a little bit, but impulse, like our other terms, has a very specific definition in physics. We already talked about momentum, and momentum is the mass is an object's mass times its velocity. Now we're going to talk about impulse, and we're going to talk about the relationship of impulse with momentum, and then we'll have some other topics in Chapter 6. Up till this point, when we have looked at forces, we have either looked at a static force. If you remember the scaffolding with the painters, we had the luxury of measuring the tensions in the line because the forces were always acting and they were consistent. Or when we dropped a ball, the force due to gravity was consistent. In the real world, we can have consistent forces like somebody pushing on a car and trying to get the car to accelerate or change its velocity, or we can have a very short duration force like a bat hitting a baseball. The idea of impulse will help us take that into account. And for impulse, we're looking at the force relative to the time during which that force is applied. Here is your equation that you need to commit to memory. So impulse is my force times the amount of time that I am applying the force. And up till this point, we have not taken that into account. We've either said that there is a force or there is not a force, and we haven't talked about the result when we apply a force over a given period of time. So for impulse, we could look at perhaps a short force over a short time interval, and that will give us a very small change in momentum. Recall that momentum is mass times velocity. The alternate would be if we had the same force and we apply it for a longer time interval. If I push you for a moment versus if I push you for a little while, we will get a different change. The other way to look at it is, or another way to say that, is if I'm pushing with the same force at twice the time, then the second time has twice the impulse and will be twice the change in momentum. It's a lot of words to keep track of. All right? What you need to remember, impulse is the magnitude of the force, which also implies the direction, and the time over which you apply the force.